So here, the question is, given two data points, how to find the support vector machine. So to solve these problems, you always need to draw a diagram, because support vector machine is geometrically is the one that maximizes the margin. So you need to visualize the margin. So it's very difficult to do actually in three-dimensional spaces. So it will be, most of the questions will be on two-dimensional spaces. And so here we have 0, 0. This is the point 0, 0. Let's say x1, x2. It's labeled 0 as well, I think. No, it's actually labeled 1. 1. And the other one, 1, 1, it's labeled 0. So what we are trying to do is you want to use the line to separate these two. And it should maximize the margin. So if the line is like this, the margin will be that, which is 1, 1 square root 2. And if you try something else, for example, if you use this one, then the margin will be this plus this, which is just 1. 1 is less than square root 2. So that's not a good one. Let's try another one. So suppose we want to move it here. Then the margin is this one, and the other one is not going there. It's because the margin should be symmetric on both sides. So the margin is square root 2 over 2. I mean over 4 multiplied by 2, so it's this. So obviously smaller than square root 2 as well. So no matter where else you put it, it's always going to have a smaller margin. So the one you want is this green one that's highlighted. And this should be, after the training, what the support vector machine should look like. So then the next thing is to just figure out what equation this is. So this equation should represent W transpose X and plus B is equal to 0. So we know that from the question given, we know that B is 1 already, so we just need to figure out the W transpose part. And it's equal to 0, so let's actually just first write down this expression. So this says x2 is equal to 1 minus x1. So you use intercept plus the slope times x1. The slope is minus 1, so 1 is the intercept, and minus 1 is the slope. So you can write the equation like this, and somehow you manipulate the equation such that it looks like the weights dot product with the axis. So this will be x1 plus x2 minus 1 is 0. This is not right. We want plus 1 here, so we want minus x1 minus x2 plus 1 is equal to 0. So then we know that this would be our minus 1, and minus 1 would be our w's. So that's how we get these.